Alright, in this presentation I'm going to talk about the interaction with devices, hardware, as well as the data. Now, when we're programming, one thing that we want to make sure that we understand in terms of what ends up happening and the importance of programming, so how it interacts with everything. So let's take a look at this real quick. So you have a typical user that interacts with an operating system or set of programs. This is going to be referred to as software. Software gives us the UI or GUI, simply referring to as the user interface or the graphical user interface, which then interacts with a device. Now again, it doesn't have to be a computer anymore. There's plenty of different things that are out there, doorbells, light bulbs, etc. And this is going to be a specific hardware. If we think about the processing cycle that happens, we do things and we don't really know what goes on behind the scenes. So let me kind of explain in terms of what happens with the program and the interaction with everything. So we have either a user or program that needs to input information. That information then goes and gets stored in short-term memory. And whatever information there may need to get processed by the processor or the CPU, right? Central Processing Unit. And this is basically what I consider to be the workhorse of the system because it does a great job in terms of calculations. Now, once information has been processed, it gets saved back and to some type of output device, such as the screen, maybe back to a file, or even to a printer. And if we want to save the data long term, so we have long term storage, such as hard drives, etc. If we look at the interactions that people have with the operating system, it's something along like this. So when you look at the operating system, you got to think about the core, the heart of the operating system is referred to as the kernel. Now, as of right now, we have either 32-bit or 64-bit operating systems. These operating systems then basically help interact with the different hardware. In order to interact with the hardware, we also need another component here referred to as the device drivers. From there, we have our applications, the software that basically ends up creating the data. So you can see the importance of the different elements that we need to have programming done for. And then the other side is we have a lot of different utilities and tools, more specifically for resource management. And to give you a quick snapshot, this is just some of the many different resources that one would manage, such as user accounts, disk drives, logs and events, performance, system-related events, hardware again, printer, and remote management, remote access. So this is what all is needed programming wise to work with the different elements here. Now real quick, let's take a look at the OS model. Now again, this is just putting things in perspective. So we have our user interaction that interacts with the software component, such as applications and operating systems. And then we have our system or device interaction, where we interact with the different hardware, right? Processor, RAM, storage, different I/O components, and our peripherals. Now, the operating systems that we have are based on different vendors, and let's kind of acknowledge and put things in perspective here. So we have Microsoft Windows, we have Apple OS X, and then we have Linux and their distros or distributions, because there's many different flavors of Linux. Then we have our Android platform, Apple iOS, and then the Chrome OS. And I want to highlight that basically the top three over here are designed to work on a desktop system, whereas the bottom are designed for a mobile device. Now there is kind of slowly but surely coming to a convergence between the two different platforms, but mobile devices are quite unique that one, clearly, they're portable, they need battery, which means that they don't have enough processing power as its counterpart of the desktop. So there's still that uniqueness between them. All right, another perspective here is looking at the vendors again and introducing some new terms. So we have Windows and Apple. Their operating system is going to be referred to as closed source, which simply means that the source code, all the programming code, is not available to the public. Whereas Linux and various Google components they're referred to as open source, meaning that you're able to see all the programming that has gone into writing the code. OS types, once again, just want to kind of bring things to perspective that we have specific operating systems for desktops, for servers, for mobile, and then we have another key term here called embedded, such as your Chromebooks and your smart TVs. And another type of configuration is virtualization. Now, if you think about software, it could be placed in different categories. So again, we have their operating system. From there, we have one category of games where it's fun and also used for learning as well. We have another set of category called production for our data, which ends up creating a lot of data files. Coding and development, and then we have another category for utilities, tools for resource management. So again, all this requires some level and some degree of programming. Real quick on the hardware requirements, if you notice that a lot of the devices have specific hardware, a lot of software operating systems require storage, CPU, and RAM. So these are the main components. Other components may require specific video graphics, video resolution, network connections, and other peripherals. Now, one more last thing here is the operating system environments. So if you think about this for a moment, we have an environment for the home and an environment for a business. Now, we may utilize some similar tools, but the bottom line, things are managed differently. So in a home, we manage things individually. Where in a business, we have the desktop, which we refer to as the front end, and then we also have the server, which is the back end. Now, in a home environment, this is what we refer to as decentralized management, because typically most individuals at home, they don't have a central system where everything is all tied into. In the business environment, that's going to be all centralized management because everything is tied into sharing the information. So there's a lot less redundancy in terms of creating accounts. Managing resources is just on a different level in a business environment. Now, a couple of things here in terms of the units of measure. Everyone should be kind of familiar with these particular terms. So let's quickly go over these. So we're going to start out kind of on the bottom half, and you notice that we're starting out at 10 to the power of -3. So this is basically milli with the abbreviation letter of little m. We have micro with that abbreviation. We have nano, which basically 10 to the power 9 is a billionth. You might have heard of like nanotechnology, nanoparticles. And that utilizes a lowercase n. Now, as we go up now, we have kilo, right, which is 1,000. And that's utilizing lowercase k. Now, that is the scientific notation because uppercase k was actually reserved for the unit of measure of Kelvin. We have mega, right, 10 to the power 6, which is basically 1 million, so uppercase M. Giga, right, uppercase G, a billion. Tera, uppercase T. Peta, with a P, and then exa, and uppercase E. So if we look basically at this, we have processor speeds that are in the gigabyte range, and then our storage are in the terabyte range. And that's pretty much it with the device interactions. So it kind of gives you a perspective in terms of what programming is involved and how we interact with the different hardware, software, and create the data elements.